Hello everyone, welcome to RU Learning Academy. So today again we are here with a new topic where we will be knowing about how a TLD batch is rerouted. So without a further delay, let's move on to our topic. So before we move to our topic, TLD readout protocols, let's know what is actually TLD batch. The TLD, which is abbreviated as thermoluminescent dosimeter. So what is TLD? TLD is a device which is a passive radiation monitoring device. It is used to measure the radiation doses, and it actually monitors the radiation doses, which is an ionizing radiation type, which is used by the radiation workers in the radiation areas where a crystal is heated to release and to look for the intensity of a light. That intensity of the visible light is measured as per the amount of radiation received by the individual. Now, when we come to the working principle of TLD, as I said, the full form is thermoluminescence dosimeter. This TLD batch works on the principle of thermoluminescence, which means thermo means heat, luminescence means the property to emit light. So here, when we talk about the TLD batch, certain crystals are used, such as lithium fluoride, CaSO4, which stores the energy when exposed to X-rays or gamma rays. Now, the most common crystal which we use in India is CaSO4, calcium sulfate doped with dysprosium. Now, when the crystals are heated, the stored energy is released as a light, and the amount of light always is directly proportional to the radiation dose received by the individual. Now, so what is where these materials are used? So, inside the TLD batch, there are small chips, and the most common type of crystal which we use is lithium fluoride, but in India we are using calcium sulfate doped with dysprosium, the most commonly used chip by the BARC. Now, the processes of TLD readout processes comes out through various steps. First thing we note is the wearing period. So each and every worker should use the batch for 3 months, 1 quarter, like this. Now, where the batches are on usually on the chest level, outside the lead apron for interventional work and research purpose, inside the laboratory always. Now, please keep in mind we actually wear the badge inside the lead apron because it measures and monitors the dose received after penetrating the lead apron. Now, sometime for research work and interventional works, if anyone is wearing the badge outside the lead apron while sending the badge to the ARB, they have to mention this badge has been worn outside the lead apron. The time period for the authorized TLD batches are 3 months, and should be sent to the authorized TLD labs such as we have Avantech, Ultratech, and Rantech. Example: Berg, Mumbai, or to the ARB approved labs. Next thing is once the batches are sent, the receipt of the TLD batch happens within the TLD laboratories. So you can see in the image the batches are being received to the TLD labs in the corner. So what the batches actually does for the batches are scanned as per the worker details, and also the control batch along with the batches are sent. So what is actually a control batch? Control batch is also called as a background batch. It actually is measuring the radiation received from outside the scanner room. Now, the control batch is kept in radiation free areas in hospitals. What does it measures? It measures the background radiations. The third step, once the batches are received in the TLD batch laboratories, we are going for the opening of the batch. So actually when we see in the image, this is the TLD chip. You can see here there is a TLD card where it has a TLD chips, the white colored discs, small round chip. So the plastic, this card will be coming into wrapper. The plastic batch is open, and inside we will find the TLD card. So there is a plastic through which the batches are wrapped. Next, there are small white crystals which we called as the TLD chips, and these chips actually store the radiation information. That is, these chips are made up of LIF or CaSO4 doped with dysprosium. Next comes is the handling check. So before reading, the lab ensures that there is no contamination, no physical damage, and correct positions of the chips. If any damaged batches are there, that is unreliable and they are kept inside. The next step is hitting the in the TLD reader. So the most common important step of TLD badge is all these discs should be read out in the TLD reader. So the card is inserted into a TLD reader machine and the chip is heated in a controlled manner. So the temperature to read out the badge is approximately 250 degrees centigrade to 300 degrees centigrade. So when these chips are heated, the stored electron escapes and the energy is released as a form of visible light. And this thing is called as thermoluminescence glow. So once the light is emitted, it is detected by the photomultiplier tube, and this photomultiplier tubes converts the lights to the electrical signals. So more the light, more will be the radiation exposed. So we can see here these are the glow curves by which our informations are formed within the TLD. So the curve has two axes. The x-axis will have the phosphotemperature and the y-axis will give the relative thermoluminescence intensity, which are measured in degree. So the curve which forms the information is called as glow curve, and this glow curve is actually what? It's a graphical representation between the temperature versus light intensity. Each peak corresponds to the stored radiation dose, and the entire doses received is analyzed by the computer as a calculated dose. So this is a TLE reader, and this is a step how we process the image. Now, coming to the dose calculations, the system converts signals into what type of doses? It's a personal equivalent dose and it is measured in millisievert. The background radiation, which is coming from the control batch, is now subtracted. And this is how the final reports are created in the form of numericals, which will have the details of worker name, batch number, monitoring period, monthly dose, and the cumulative yearly dose. So if it is a January March, the first reading will be there. Next, on the April slot, they will give the next reading along with the January, and on the fourth month, they will give the total entire doses of the last consecutive 9 months. So next is who is receiving this reports. These reports are always available to the RSOs of the hospital, and also a record is maintained to the ARB. Now, after this, all these records are read. Now it's time to make the batch again reusable. So resetting of the batches happens after annealing. So after the reading, the chips still contains trapped electrons, so it is now annihilated. Now there will be a erasing temperature. So all the chips are heated at a high temperature of 400 degrees centigrade, which is used to erase all the old data informations, and now the batch again becomes for the reusable. So the flow chart to remind us is the waiting period of 3 months is important. After each and every 3 months, the batches are sent to the labs, TLD labs authorized by the ARB. We have Avantech, Rentech, Ultratech. Once these batches are received, they are opened and they look for contamination and damages. If damages are found, that batch will be kept unrevealed. Next, the TLD chips are heated in the TLD reader, and from their lights are emitted. Next, what happens? The PMT detects this light and this is sent to the computer calculates, which is formed in the calculated dose. Next, the reports are generated in a paper format, and then finally it is sent to the RSOs, and ARB also maintains a record of the doses. Then the annealing process happens again at a 400 degrees centigrade, and the batches are made reusable. Next thing is the dose limits, and the ARB dose limits of the radiation work is 20 millisievert per year, and and for average of 50 millisievert in a single dose, and the public doses will be 1 millisievert. So this is all about our TLD batch readout processes. If you like the session, please press like. There are some brainstorming questions you can try it out, and you can also mention in the comment about this.